Hello, welcome to this demo. In this demo, I'm going to go over first the requirements for the algorithm and for the project. Next, I'm going to go over the algorithm architecture, and lastly, I will do the demo, the testing of the algorithm. With no further ado, first is the requirements for the algorithm. So first, I've stated on the report that the algorithm needs to be generic, which means needs to work with any given field. Secondly, the algorithm needs to be the complete algorithm needs to be a combination of rule-based and natural language processing approaches. Thirdly, it needs to identify and match correspondences, narrow down those matching correspondences to a unique field. Then it needs to give probability for any lemma that is found, identify the part of speech of that lemma, and finally be able to store to the dictionary when the field is unknown. With that in mind, I've created this architecture. So the architecture, it has the two requirements, the two main requirements, which are the machine learning, which is the neural network part of it, and then the rule-based. So the way how this works is the algorithm the user first interacts with the machine learning aspect, which handles a particular aspect of the fields as it's been trained to, and then if that particular aspect does not fulfill what's required or does not give the field or the lemma, it passes that field to the secondary aspect of this algorithm, which is the rule-based, to try and find a match. The machine learning has two parts: the part of speech prediction and lemmatization. So first you have it receives an input, it detects the part of speech. If it's in English, if it's a complete full word, it detects part of speech, and then it narrows down to a unique field. If the field is found, it then displays the lemma and the actual and the probability of that lemma matching the field that you have given to it. If it's not found, then it goes, as mentioned, it goes to the secondary search, which is the rule-based search. The rule-based has three components to it. First, it searches, if the word is given, it searches in the dictionary for the whole word. If it's particularly if it's less than 3 characters, it searches for the whole word. If the word is found, then it then passes back to the machine learning aspect to be added to the dictionary with the correct part of speech, and then it's displayed. If it's not found, it still searches letter by letter, matching to all the fields that are in the data set. If it's found using this approach, then it still passes to the algorithm, to the machine learning again, to be able to store and display. And lastly, if it's not found, then the user has to add the field manually. After adding the field manually, it's added to the dictionary and finally displayed. With this architecture in mind, I've built the algorithm. Here we have the algorithm. First, I'm just going to go through some of the libraries that I've imported. So I've imported the Open Natural Language Processing, which contains the model for the algorithm. I have two data sets. It's data. This is the data that I've used. It's about 300,000 columns, and I have, this is just a sample data. I didn't use it. I use it for testing, and we have our bin. This is the model. It's in bin. It's a bin that I've imported into the machine to be able to use. It's a pre-trained model for lemmatization. So with that, I've created. With that in mind, I've created these three files. These are the three Java classes that are mainly used. I've split the algorithm into two aspects. First, I have the primary search. Essentially, the primary search contains the primary search, as it says, and the secondary search. The primary search is the machine learning, and secondary search is the rule based. So I did this to allow me to test each component individually before integrating them. And then I've also created, now this is the full algorithm containing both primary using the bin file, which is the model, and then you have your secondary method using the if statements, because the rule based is essentially if statements and trying to find the matching lemma. Now, interacting with this, essentially, I've added the main UI, which allows you to interact with algorithm using I've used JPanels. Essentially, you interact with them, and I've called each of the classes in here. So here they are. So with no further ado, I'm just gonna go ahead and run this. So first, we have two panels. The first panel is the whole algorithm. This is the main algorithm, and then the second panel is search. You have the machine learning and the rule based separate. I've put them this way as referred before in order to be able to test them individually. So let's start by testing first the rule-based machine learning. So with the machine learning, for instance, if I look for the field client, it should return back client field, so it matches a field. However, if I search for CLT, which is let's consider this an abbreviation for client. If I search for that, it won't find the word the field client. Similarly, if I search for the field product, it should return product. It should match the field product. However, if I search for ProDT using the machine learning, it shouldn't find, or it's not able to find. On the other hand, if I search for the same field using the rule-based, it should be able to find these fields quite easily. So here, product matches products. It's able to find still. If I search for product, it should be able to find product. Should be able to find products matches products. So the same way, if I still search for client, which is the first field, it's able to find. So this is, I've certified that it basically two approaches are working is required. Now, going to test the main algorithm, there are three aspects. First, it needs to be able to find the lemma, which is the match. Second, it should display the probability of that lemma and the actual field. So let's test the same fields that we tested on the primary and secondary, which is the rule based and the machine learning. So let's search for the field client, for instance. If I process, so it gives me the field client. This is the field that I searched for. This was my input, and then the match is client as required, and then it gives me the probability of that lemma using this. This was made using there's the probability. So the lemmatizer itself has a probability not function. It has a probability method that allows to, if I can find it, that allows to print the probability of a tag. Let me just probability. Not one word. Find, yes. So using this probability, I was able to amend the probability to the tag when it's being printed. Going back to this, so we can search for another field. We can search for another field is product. If I search for product, it should return me product with a probability of 92%. Process again, 92%. Similarly, I can still search for T. That should return me product. It returns me product. However, the percentage now has changed to 47%. Sorry, which means the probability of product mapping to product is 43%. I can also search for fields like such as manufacture. It should give me manufacture 92%. However, if I search for MFR, which is some of the letters MFR that are present in the field manufacture, it will give me the field and the probability. The probability, however, is 34%. The probability is explored in the final report. Is one of the things that I explore, which is I find it to be crucial for this algorithm. I hope this it makes sense. I've added this code to the to GitHub for further analysis. And if there's a need to run the code, I'll also put instructions on how to run the code. Thank you.